Hello, welcome to lecture number 3 of week 7. In this lecture, we will explore generalized mean value theorem. In the last lecture, we have focused on mean value theorem in general case of Cauchy mean value theorem, in which we have seen that there are two functions fx and gx, and both are continuous in a closed interval ab, both are differentiable in an open interval. Then there exists a point C, at least a point C, such that we can find out the slope of the tangent line at that point C. That means f dash of C is equal to fb minus fa divided by gb minus gc. That was the idea, b minus a, not gb minus gb, but b minus a, right? But can we have three functions, and can we generalize this Cauchy mean value theorem in a general case? If it is, then we will explore in this lecture that how their structure will be and how they can apply on some of the problems to get the solutions. So, to go through the generalized mean value theorem, let us first recall Lagrange's mean value theorem as well as the Cauchy mean value theorem, and then we will go through the generalized mean value theorem. So, Lagrange's mean value theorem, if you remember this one, that was there was one function which is continuous in a closed interval AB, which is also differentiable in an open interval AB. Then there exists at least one point C such that we can have the slope of the tangent line at that point C, f dash of C we call it, that can be calculated using the end point value and the argument value. That means fb minus fa divided by b minus a. Fb minus fa is nothing but it is the functional value, difference of the functional value at the end points, and b minus a is nothing but it's the argumental difference between the end points, right? So that will be our criteria, and it will help me it will help us to find out some of the derivative as well as some of the missing points, right? Missing points, missing terms, and so on, right? So, and what was the Cauchy general case for mean value theorem? There was two function fx and gx, and both are differentiable in a closed interval, and both are continuous in an open interval. And we suppose we assume already that the second function g dash of x is not equal to 0. That means throughout a into the interval ab, the gx is not equal to 0, either it is less than 0 or greater than 0. Then we have the ratio of the slope of the tangent at point C for the function f as well as g. That means we can calculate f dash c divided by g dash of c as equal to the functional value of fb minus fa divided by the difference of the functional value of function gb minus ga, right? So I believe that it has been we had explored with some examples, as well as we had explored its applications as well. So as you can see here, this is general case for the Cauchy mean value theorem. We can have the ratio of the slope of that tangent line at the point C, and that is equal to the functional value, the difference of the functional value of f divided by the functional value of g. Now, generalized mean value theorem, we can extend this thing from the two function to three function, and you can have the various type of the generalizations, but we kept ourselves for three function here. So we had assumed that there exist fx, gx, and hx are three differentiable function in a closed interval ab, and they are three continuous function in a closed interval ab, and these are differentiable in an open interval ab. And one quantity, that is fx, gx, hx in the matrix form, fx, gx, hx, and fa, ga, ha, fb, gb, hb. We have defined this quantity, then there exists a real number c between AB such that d dash of c is equal to 0. That means we had f dash of x, g dash of x, h dash of x, fa, ga, ha, fb, gb, hb. The matrix is going to be 0, right? So that's our idea, and so this is the mean value theorem. Let me give you once again. So what we have done, we have taken one closed interval AB, A to B, and we have assumed three functions f, g and h. Both three functions, all three functions are continuous here, are continuous in closed interval AB, in a closed interval AB, and it is differentiable in an open interval AB, right? And we had defined one matrix in determinant form. So one determinant fx, g of x, h of x, if a, if b, g a, g b, and h a, h b, right? Then for at least one point, for at least one c belongs to a b, such that this d dash of c is equal to 0, right? So we are not providing the proof here because there is no need to, I mean, at this stage you don't need the explicit proof for that, but one can attempt to prove this. This will be quite easy. You have to just construct a function in such a way that the determinant is going to be related with fx and gx, and then you will find out the answer, right? So since d dash of c is equal to 0, it's given here. So this is determinant of this, right? So if we take gx equal to x and hx equal to 1, then this will be a Lagrange mean value theorem. You can check that this will be a Lagrange mean value theorem. We can check here by giving here. So gx of x, that means we have fx, x, hx equal to 1, and here f of a, f of b, and since gx equal to x, this means this ga is equal to a and gb equal to b, and since h is equal to 1, so this will be 1, right? And then d dash c, this is d dash, so d dash c is this, and x equal to 1 here, right? And this is going to be 0. So this is going to be 0. So f dash of c, is totally become fb minus fa divided by b minus a. That's the Lagrange mean value theorem, right? Similarly, you can check that if I put only hx equal to 1, then it will be a general case of Cauchy mean value theorem. I will check it for you. So f dash of c here, and here g dash of c, hx equal to 1, so h dash of c equal to 0, and f of a, f of b, g of a, g of b, right? And this will be hx equal to 1, so 1, so h of a equal to 1 as well. This is the constant function, so here, and this is equal to 0. So now you can just simplify. This is the 3 cross 3 matrix, a square matrix, so we can find out the determinant very easily. So this will give you f dash of c divided by g dash of c directly is equal to how much? F of b minus f of a divided by g of b minus of g of a, and this is nothing but Cauchy mean value theorem, right? So we have seen that if I put gx equal to x and hx equal to 1, it will leads to the very basic mean value theorem, that is Lagrange mean value theorem, which was valid only for a single function. And if I put only hx equal to 1, then it will comes out to be general case of Cauchy mean value theorem. And so there is one example here. So the example says that validate the hypothesis of general mean value theorem, and it has given the three functions fx equal to sin x, gx equal to cos x, hx equal to 1 on an interval 0 capital A C B to pi by 2. This is our interval, right? So, how to do this? So, C belongs where? C belongs at 2 points A and B, and this B is less than pi by 2, right? So, here fx is given sin x and gx is given as cos x, hx equal to 1. So, function f, g, h are continuous and differentiable. Sin x is continuous in a closed interval 0 to pi by 2. It is differentiable in an open interval 0 to pi by 2. Gx is also a continuous function. Cos of x is continuous function in a closed interval 0 to pi by 2. It is differentiable in open interval 0 to pi by 2. And hs is a constant function which is continuous as well as differentiable in an open interval or closed interval, right? So, function f, g, h are continuous and differentiable. Thereby, generalized Cauchy mean value theorem on taking a, b as a end points, we have f dash of c, g dash of c, h dash of c, and f a, f b, g a, g b, and h a, h b is equal to 0. This is the determinant, right? So, how much it will gives you? Just simplify this version. So, find out f dash of c, f dash of c here. So, this will be comes out to be f dash of c is equal to cos of c, g dash of c is equal to minus of sin c, and h dash of c is equal to 0. This is a constant function, right? So, put this, this will comes out here cos c minus sin c 0, and f a equal to sin a, f b equal to sin b, g a equal to cos a, g b equal to cos b, and h a equal to 1, h b equal to 1, and this is equal to 0, right? So, simplify this determinant, 3 cross 3 matrix determinant. So, how much it will comes out to be? You see here sin a minus sin b divided by cos a minus cos b is equal to cos c divided by minus sin c, right? Directly we had written here, and I think I had used in this one as well. See the difference between these two and difference between these two, the ratio of these two differences will give you this ratio. So, we had used the same thing, sin a minus sin b divided by cos a minus cos b here is equal to cos c minus sin c, and cos c minus sin c is going to be minus of cos c. So, we can change this one and it will comes out to be, this is minus cos c, right? So, sin a minus sin b is into cos a minus cos b is equal to cot of c, and that was what it was asked. So, that sin a sin b divided by cos a cos b equal to cot c, where 0 a to c b pi by 2. Now, the same thing has been asked by Cauchy mean value theorem. The previous question was asked for generalized mean value theorem. Here it was asked for Cauchy mean value theorem. So, here fx equal to sin x, gx equal to cos x, and what was the Cauchy mean value theorem? It was f of b minus f of a divided by g of b minus of g of a is equal to f dash of c divided by g dash of c, right? Put these values. So, what will be the fb? Fb is equal to sin b, right? Why it's written as this is sin b, right? And then minus of fa equal to, so this will be okay. You can change the both side. So, sin a minus sin b, cos a minus cos b, we can change in both sides, right? Is equal to cos c divided by minus sin c, and this will comes out to be sin a minus sin b, cos a minus cos b is equal to cot c. This is minus cot c, right? Now, can we validate the hypothesis of general mean value theorem for these three functions on 1, 2? So, here it is given the closed interval 1 to 2, and we have three function f is equal to f of x equal to x, g of x is equal to x square, h of x equal to x cube, right? And f dash of x equal to 1, g dash of x equal to what? 2x, and h dash of x equal to 3x square. Now, using the generalized mean value theorem, we had defined d dash of c is equal to how much? F dash of c. F dash of c is equal to 1. G dash of c is equal to 2 twice into c, and h dash of c is equal to 3c square. Fa, what will be the value? Fa equal to x. So, that is 1, right? And Fv is equal to 2 here, and Ga equal to 1 ka square is equal to 1, Gb equal to 2 square equal to 4, H1 is equal to 1 q is equal to 1, and Hb equal to H2, that is equal to 2 ka q equal to 8. So, this is given, and this is equal to 0. So, this will give you, just simplify it, since the one row is 1 1 1. So, the simplification is quite easy for us, and how we can do this? You can change this value like to first row to second, first column to second column, and so on. But without these, we can also do the same thing. This will comes out to be 6 c square, right, minus 4 cross 3 equal to 12 c, and plus 4 cross 1 equal to 4. This is equal to 0, right? We can take the determinant, and this is equal to how much? This will give you a quadratic in C. So, C has the two values, which one? 3 plus minus of root 3 divided by 3. So, this will comes out to be 1 plus minus of root 3 by 3, right? So, that means we have one of the root which lying between 1 and 2, and one of the root which lying outside of 1. So, one root is lying here and one root lying this side, right? So, this one will be our choice. So, what will be the C? So, C I have to choose 1 plus root 3 by 3. That is our answer, right? Okay. So, we had already find out the latest one is 6c square minus 12c plus 4 equal to 0. So, take c as a x, and as you can see here, we have the graph for 6x square minus 12x plus 4 and y equal to 0. So, this will be the graph for 6x square minus 12x plus 4, and as you can see, this is the 1, and there will be some of the points here which minimizes the curves, right? So, that is the 1 plus of root 3 by 3 is somewhere here. So, that means C is the point of 1 plus root 3 by 3 validate the generalized mean value theorem. So, now I think these three examples will make the generalized mean value theorem in an easy way. If a question is given related to two functions, try to use a Cauchy mean value theorem. If the question is given related to three functions, and then find out something, and then if they ask about finding slope or tangent or some missing terms and some point C such that f dash C or something like that, then you have to use generalized mean value theorem. In this case, the putting a gx equal to x and hx equal to 1 will leads to the basic Lagrange mean value theorem, which is only valid for single function fx. If you put only hx equal to 1, this will lead to the Cauchy mean value theorem. That means generalized mean value theorem can be converted into Cauchy mean value theorem and Lagrange mean value theorem by putting the suitable choice of Gx and Hx. Similarly, generalized mean value theorem is an extension of the Cauchy mean value theorem. It is not a new thing, but it is just an extension of a Cauchy mean value theorem. Do you think that it can be extended for a 4 function or 5 function and more? Just ponder over it and let me know. If it is, then how we can derive the d dash c, and if it is not, why not? The basic logic you have to put for that one, right? So I think this will be the end of this lecture. Thank you so much.